So the setup is this. We're talking about how much sleep do AP Stats students actually get. Everybody says teenagers should get 8 hours. Of course, school starts at 5 a.m. They're up late doing homework, practice, all that other stuff. So they get like, what, 3? So anyway, so to test this out, I went through and I sampled 8 of my students from my class yesterday. And these were the numbers that they came up with. The original experiment said 10. I had 2 people who were randomly selected who didn't respond because they had the black Zoom screen of death. Anyway, so if I average those out, I got a mean of 6.375, and I got a standard deviation of 1.188. So what are we going to go through and do? So the hypothesis for this and the parameter is obviously the true mean hours of sleep for Mr. Hayes' AP Stats students. We could actually for AP, for my stats students, assumed we're going to say the null hypothesis is the mean of 8 hours of sleep, because that's what we're trying to disprove. And then the alternative hypothesis is that it is actually going to be lower. And again, it could be lower, higher, whatever. But in this case, since my data seems to be pointing lower, that is what I'm going to look at. So for conditions, this won't be a surprise. 10% random, yes. 10% condition. 10 is not, that actually should be an 8. 8 is not less than 1/10 of all my stat students. I wish I had 80 AP stat students, but something that everybody needs goals, right? So we're going to go ahead and proceed with caution there. Normality, there is no real strong skew or outliers on that, so we'll have to see where things go. But we'll still go through and see what the form says. So here, mu is equal, mu of x is equal to the mean of 8. So again, remember this. We're always going to say and make the assumption that our sample mean should be what the population mean is, which is the same as what we have up in our null value. And then over here, our standard deviation is going to equal to the standard deviation that we find over square root of n. So we're going to go ahead and use the standard error of x as our standard deviation divided by square root of n. So I ended up having a mean of 8 and a standard deviation of 0.420. So we're going to do the picture and everything. Now, when you draw the picture, again, much like what we did with means in confidence intervals, you would normally think normal, except that we don't know if it is normal for sure. And so we're going to use the t-score. So we're going to do t times the degrees of freedom, t degrees of freedom. So like here I have t of 7. That means I have 7 degrees of freedom. Here is my specific stat formula, or t-score formula, sorry. And then I'm plugging in all the parts. So when I calculate that out, I get a t-statistic of a negative 3.869, which obviously is not boding well for the null hypothesis. So when we go through and do that, we're going to go through and use table B or technology. And either way, when you do this, you've got a negative 1.9 or 10 to the 99th. Upper value is negative 3.869, and the degrees of freedom is 7. And again, that's part of the reason why this is so helpful, because then you make sure that you're setting this up correctly, and your p-value turns out to be 0.00307. So very small chance that my students actually get 8 hours of sleep a night. So what conclusion can we make? Well, because 0.0031 is less than 5%, we reject the null hypothesis and have convincing evidence that Mr. Hayes' AP students' mean number of hours of sleep is less than 8 hours. So we're going to formalize this a little bit in part 2. Make sure you guys check us out over there. We'll also go through check your understanding. And then tomorrow we'll go ahead and formalize this a little bit more. And I'll see you in a few minutes. Bye.